Hello viewers, welcome to IGCSE Computer Science Boolean Logic Crash Course 1. At the end of this tutorial, you shall be able to identify and use the standard symbols for logic gates, define and understand the functions of the logic gates, draw a truth table for each of the logic gates, and finally, use logic gates to create given logic circuits from a logic expression. The first logic gate we shall be looking at is the NOT gate. This gate accepts one input and reverses it to output the opposite value. The symbol is given below, and the logic expression is x equals not a or x equals bar a. The truth table has two possible combinations which are derived from the number of inputs, and the formula to derive this combination is 2 raised to power n, where n is the number of inputs. So in this case, there is only one input, therefore 2 raised to power 1 is 2. From the truth table, when the input is 0, the output is the reverse, which is 1. And when the input is 1, the output is 0. The AND gate accepts two inputs and outputs 1 only when both inputs are 1. The symbol is just like a D, which accepts two inputs A and B and the output X. The logic expression is X equals A and B, or X equals A dot B. Notice that the output comes on the left hand side and the inputs come on the right hand side. The truth table comprises of 4 possible combinations, which are of course derived from 2 raised to power 2, which is 4. And for the first column, we are going to complete the inputs with Boolean values or Boolean constants, 2 zeros and 2 ones. The next column becomes alternates of 1 0, 1 1, 1 0, and 1 1. So in that case, it's more like saying B column has 0 1 0 1 and A column has 0 0 1 1. The output is 1 only when both inputs are 1. The OR gate accepts two inputs just like the AND gate and outputs 1 when any of the inputs or both inputs are 1. The symbol is like half of the moon, and the logic expression is given as X equals A or B, or X equals A plus B. The truth table comprises of 2 possible combinations. The A column has 0 0 1 1 and the B column has 0 1 0 1. The output is only 0 when both inputs are 0. Otherwise, the rest are 1. The NAND gate accepts two inputs like the other logic gates A and OR, and the output is 1 only when both inputs are 0 or either input is 1. It is, however, said that the NAND gate is the reverse of the AND gate, and the symbol is similar to the AND gate symbol, except there is a NOT before the extension of the output X. And the logic expression is X equals A NAND B, or X equals bar A dot B. The truth table shows that the outputs are 1 based on the conditions stated above. And of course, the only time the output is 0 is when both inputs are 1. Recall that the AND gate has the output of 1 only when both inputs are 1. Otherwise, the rest are 0. So this is the reverse gate for the AND gate. The NOR gate is the reverse of the OR gate. It accepts two inputs and outputs 1 when both inputs are 0. And the symbol is similar to that of the OR gate, except that there is a NOT before the extension of the output X. The logic expression is X equals A NOR B, or X equals A plus B all bar. And the truth table shows that the output is 1 only when both inputs are 0. The rest are 0. The XOR, or otherwise known as the exclusive OR gate, accepts two inputs and outputs 1 when one of the inputs is 1. However, if both inputs are 1 or 0, then the output is 0. In other words, if both inputs are the same or have the same binary constants, then the output becomes 0. The symbol is similar to that of the OR gate symbol, except that there is an arc before the logic gates, which looks similar to the OR gate. The logic expression is X equals A XOR B, or X equals A plus B. The plus in this case is enclosed within a circle. The truth table shows the proof of the rule stated for the XOR gate, which means that the outputs can only be 1 when either of the inputs and not both inputs are 1. Let's take a look at an example derived from IGCSE Computer Science question for May-June 2023, question 9A. The component is 2, 1. Consider this logic expression: Z equals not A or B and B XOR C. Draw a logic circuit for this logic expression. Each logic gate must have a maximum of 2 inputs. Do not simplify this logic expression. Let's take a look at my solution to this question. Just bear in mind the equation or the logic expression. Z equals not A or B and B XOR C. Here is my solution. As you can see, this logic circuit represents the solution to the question in the previous slide. In translation, not A or B, which is similar to what we have over here, and B XOR C gives us the output Z. So this will be the end of this Crash Course 1. I hope to see you in the next crash course on Boolean logic. Thank you for watching. If you have not subscribed, please kindly do so. And this will help to reach out to so many other learners. Thank you.